going to do a demonstration of our low-cost measurements of the activity of this biofilm. The biofilm grows on tidal flats like this. So we're just over the border between Netherlands and Belgium, near the port of Antwerp, background. And there's the River Scheldt, there's the nuclear power station on the other side. You see from the footprints here that it's quite a transition here between mud where we were earlier up there and the sandier shore here. We've got this nice brown colour at the surface, and that's a layer of biofilm made by diatoms. So the first thing I'm going to do is I'm going to put down a light and temperature logger, and that's been calibrated to measure the amount of light. Next up, I'm going to put in a fan. So this is just to give inside the chamber that, so we get a circulation of the air. Very cheap, $4.99 on Amazon. Just put that in on a pair of sticks, push it into the sediment, and that will create a bit of movement, a flux inside the chamber. That's 2 devices installed. So the next part is a little carbon dioxide meter that we use. This one is the Aeronet sensor, and it's self-contained Bluetooth connection to my phone. Runs on 2 batteries, and we have a set of these that we've been using on the fieldwork this summer. So we can see 415 ppm, that's carbon dioxide concentration, and it also measures atmospheric pressure and temperature and humidity. So that's going to go inside the experimental dome like that, and the whole thing is then sealed into the sediment. I just give it a little push in. That's got a very tight seal around it, around the chamber, so no air can get in or out when the experiment is running. It typically takes about 20 minutes. So we're measuring the light and temperature inside. Normally we measure outside as well. So our little experiment is set up. Start the clock, and then we'll come back in 5 minutes time and see what's happened. So remember, 422 was what we had at the start. So I'd expect the values to go down as the diatoms draw down carbon dioxide out of the air. So that's 5 minutes of measurement, and we are reading about 287 now. So the CO2 concentration's dropped by about 120 ppm in just under 5 minutes. As you can see by the dome and looking around, it is now a lot of rain coming, so we're going to wrap this experiment up here. We've taken some measurements of the biofilm with the spectral camera, and we'll take some contact cores here. So that was an early end to the measurements as the rain came down, but we got back to the base and washed down the equipment, downloaded everything, and this is just a little insight into the kind of results we get out of the low-cost dome system. So on the y-axis you've got the CO2 concentration in air starting at about 420-ish, which is normal starting concentration at this time of year. And then the 6 minutes that are highlighted are the enclosure with the CO2 meter inside, and the drawdown of carbon dioxide from the photosynthetic biofilms are decreased down to about just over 250 ppm in 6 minutes, and then the values jump back up again to air values when the dome is opened. So that's a fairly linear decrease. The light conditions were quite constant, very dim light actually during that experiment, at about 27 ppm every minute. We've had much faster drawdowns than that during the fieldwork that we did in the Netherlands, in some cases down to 0 within a few minutes. Very active biofilms, and in other cases very little actually. CO2 concentration stayed more or less constant, and that's probably the case with a very low biomass surface biofilm. So we're quantifying the amount of photosynthetic material using a special spectral camera, and that'll help us understand the results. These numbers then feed into calculations of the amount of carbon fixed on an hourly basis, on a square metre basis, starting with the known volume and known area of the plexiglass dome, and conversion factors from ppm of carbon dioxide in a cubic metre of air to the weight in milligrams of carbon dioxide with standard conversion factors. That works out as about just under 500 milligrams of CO2 on a square metre basis per hour, because we normally express photosynthetic rates per hour. And that in terms of carbon, 132 milligrams of carbon per square metre per hour. That's what we've got from that experiment on the lower shore of the tidal flat. There's actually quite a reasonably high rate of photosynthetic activity there. And if you consider that the tide is out for about 6 or 7 hours and light conditions might be higher than that for most of the time, you can easily see that you're getting up to about 1,000 milligrams. So a gram of carbon per square metre per day would be quite easily achievable, at least in summertime with long day lengths, with photosynthetic biofilms. And that's the kind of value that's up there with a square metre of North Sea water column. If there's a phytoplankton bloom, you would get similar kind of values, and maybe just a little bit less than what you would get, for example, from a seagrass meadow or from a actively photosynthesizing kelp forest. Would probably be a higher value than that, but that's just to give an indication. We've got a lot of modelling work to do, and that's where our satellite and drone images of the amount of chlorophyll will come in, and we've got lots and lots of measurements with the domes over the past week in the Netherlands to build up a picture of the mathematical relationship between the light and the temperature and the photosynthetic activity. And thank you very much for listening.